All right, folks, welcome back. It's time for our next 223 video. The bullet we're going to be shooting today is the 65 grain Cutting Edge Bullets MTH, which stands for Match Tactical Hunting. They are extremely expensive. They come in boxes of 50, and this 65 grain version is $39 a box. Now, I made a mistake when I was ordering and accidentally got 2 boxes. My internet was being particularly crappy that day, and I clicked one too many times, but it kind of works out good. We've got plenty enough to play with. So these are a solid copper machine bullet, like we've shot before with the Lehigh Defense and Maker. This is a similar sort of bullet company, it seems like. They're making these machined solid bullets. The first thing I noticed with these guys was the packaging. And at first I thought it was really quite ridiculous, because when you pull the bullets out, they're in this tray. Like, they all have their own little individual slot in this tray, and they're a pain in the butt to pick up out of there. You almost need a set of tweezers or whatever to get them out of the box. So to be honest, I thought it was just plain stupid. But as I read more on their website, the design of these bullets is a little bit different than what we've seen from other companies. They've got what they call a seal-tight band, and it's just this little like driving band type thing towards the top of the bullet. I'll show you a drawing from their website. It's just a thick little band, and then there's a little valley on each side. I'm not looking at the picture right now. You can hopefully see it on the drawing. They call it like material collection valley, or I don't know, whatever. But hopefully you can see what's going on. Now, what I was surprised about, the normal bearing surface of the bullet is 224, like you would expect. But this seal-tight band is actually 226. If I can get my calipers on it right. 226. So as far as I know, we haven't tested any solid copper bullets with this sort of design, with this thicker band around them. So I'm extremely interested to see what accuracy looks like with these guys, because, well, to be honest, we really haven't seen the best accuracy out of solid copper bullets, or brass. We've shot some brass ones. They never seem to group quite as well as their lead core equivalents, you know, the normal cup and core bullets like we are used to. But, you know, I've said it in the past, I'll say it again here, I've got to figure out how to load these at some point, because this is probably our future. I think lead-free bullets are already required for hunting over in California, and it's just going to spread from there, I'm certain. All right, so Cutting Edge Bullets doesn't have any load data on their website, although they do say you can call them to get starting charges or whatever, but they don't have anything actually published on the site. But they do have an entire reloading instructions page, and it's all about the care you have to take during bullet seating so you don't booger up that seal-tight band. They say it's soft copper and you can screw it up during bullet seating. And they also say that's why they're packaged the way they are, in that goofy tray where each one has its own little thing. Apparently they're so soft, in a standard bullet box, if they bang together, these seal-tight bands would get boogered up, and that's bad, I guess. So if you're loading these, I would definitely urge you to go read that reloading instruction page. It takes a minute to wrap your head around what the hell they're talking about, but the basics of it are, if the seal-tight band is going to be below the case mouth, you know, in the case neck, they say you should definitely use a VLD chamfering tool. Now what that means, here is a standard chamfering tool that's, you know, kind of short and fat. This is a VLD style chamfering tool. It's longer and skinnier. So if you can imagine the change of angle on the chamfer of your case mouth, the VLD is going to cut deeper down in there, right? And it's going to be a more gradual angle. So if you use a standard one, you can run into problems where it is shearing off or scraping that seal-tight band. But the good news here in 223, at least with my gun, it doesn't look like we're going to need to seat it deep enough to where the band is below the case mouth. We're going to be able to keep the band just above the mouth of our case, so we won't have to worry about scraping it up. However, I usually use a VLD chamfer tool anyway. These guys are nicely chamfered. This is the brass we're going to be using today. So hopefully we don't have any problems with scrapage, you know, scraping copper, but I'm still going to be on the lookout. Now, another thing they mention on that page, if I can get my camera to focus, there it is. They say if you take the, what's it called? The seal-tight band below the case mouth, you never want to go more than halfway down your neck, because you can end up with just not enough neck tension left. Because I think as the seal tight band goes down through there, it's spreading out that case mouth, and it's no longer going to be able to grab that bullet. So it's almost like an expander ball going down into the case mouth, spreading it out as it goes. So if you go below the case mouth, don't go too far. Hopefully that makes sense. Like I said, go read their reloading instructions page, because it kind of took me a minute to figure out what in the heck they were talking about with all of this crap. So, load data. In the past, we've gotten ourselves into trouble a couple times with unexpected high pressure when shooting some of these copper solids or brass whatever bullets. So today I'm hoping to keep the velocities and pressures pretty modest. So like I said, we've got a second box of them, so we can take what we learned today and maybe try and hot rod it next time. But at least for this one, I want to keep things modest. The powders I want to use are IMR 8208 XBR and Hodgdon Varget. I think those will give us a good opportunity for some accurate loads. We're going to shoot 23.0 grains of IMR 8208 XBR is our max charge, and we'll shoot 0.3 of a grain increments, so that puts us starting at 21.8. And Hodgdon Varget, we're going to start at 23.8 and work our way up to 25.0. Our brass is going to be Lake City. Our primers are going to be CCI number 41 primers. And I never really finished my discussion about overall length. We're going to shoot 2.260, full magazine length, right? And that puts, like I mentioned, the seal tight band just right outside the mouth of the case. Now, I assume that's no coincidence. They probably designed this bullet for a 2.260 inch overall length and standard length brass and all of that stuff. So it makes a lot of sense. Now, I did use my little split case overall length checker thingy to make sure that wasn't into the lands of our rifling. So slipped a bullet down in this guy, chambered it, and let the rifling seat the bullet and pulled it out and came out with 2.274. I did it multiple times and got the exact same number every single time. So that's awfully close. So in my gun, we've only got 14 thousandths of jump before we hit the lands. If you've got a gun with a short throat, you might want to be careful, make sure you don't jam these guys in. These are definitely not ones you just want to load at 2.260 without testing to make sure they're going to fit. So I think that pretty much covers it. Before I flipped on the camera, I went ahead and weighed out my charges. I seated my CCI number 41 primers and I weighed out all of the charges. So we're ready to start seating bullets. And I think that's the interesting part of this discussion with this bullet. So let me readjust the camera and we'll get right to it. All right, so we're just going to be using my standard Redding bullet seating die. And the good part about this seal tight band is it should make bullet seating setup pretty easy. We just use that as a guide. All right, that's pretty close. I'm going to tighten that down just slightly. Let's see what our overall length looks like right now. 2.267. And you might be able to see the band is still above the case mouth, just a touch. Now on their reloading instruction page, they do mention that the overall length to the me-plat should be very consistent with these because they are machined just perfect and all of that junk. We're just 1/1000th too long now. So that should be right about 2.260 on the number. And it is 2.260. So let's test their claim of bullet consistency. See if this next one comes out the same. Pretty close, 2.262. We'll blame my brass. So I'm not seeing any copper shavings or anything weird going on there. Looks like my seating stem did leave just the lightest little bit of a mark on the ogive, but nothing to freak out about. I think we're good. Let me seat these others and see what the overall lengths look like. 2.262, 2.2615, 2.2615, and 2.262. So I'm going to come down, try and get another maybe 0.002. See what that looks like. That one's 2.261, so that's about 1.5 thousandths. Yep, I think that's better. Now most of them are 2.260. I bet that first one's maybe just a smidgen short now. Yep, it is 2.259. But consistency looks pretty good there. Yeah, when they mentioned soft, you know, the copper being very soft, I thought for sure we might run into some problems with scraping, but we haven't. Like, these seem to have seated really well. Now with a 65 grain bullet, those of us who can hunt deer with 22 caliber, this may not be a bad choice. And in the next video, we'll shoot some of these into ballistics gel. We'll focus on accuracy here in the first video, hopefully. Then the next video, maybe we'll try and push velocity a little bit, depending on our results from this video, and also do ballistic gel testing to see how these guys expand. So I just jumped forward all the way up to our max charge of Varget, because, you know, 25 grains of Varget is a pretty full case, and it does seem like these guys are crunching just a little bit, but just barely. So very lightly compressed. But it does seem like the overall length is stretching a little bit, like 2.266. So once I get to my Varget loads, I'll monitor my overall length and just tweak the die down just a little bit as necessary as our charges get more and more compressed. But yeah, here with 8208 XBR, we've still got a fair amount of excess case capacity, so nothing to worry about here. All right, folks, I think that's pretty much it. This was a lot less dramatic than I thought it might be after reading their reloading instruction page, but that's a good thing. I like it when it turns out easier than you expected. So let's go ahead and just get out on the range. All right, folks, it's another extremely hot day on the range. The air temperature is around 96 degrees, but the humidity's 45%, which is still kind of gross, but not as bad as it could be. I've got a target at 100 yards. We're shooting at 1-inch dots. This gun has an 18-inch White Oak Armament SPR barrel, and it is a really good shooting gun. I do have my Silencer Co. Omega suppressor on there and my Magneto Speed chronograph. This is a 24 power Vortex Viper scope, and this lower has a LaRue MBT 2-stage trigger. So let's get started. The gun is warm. I shot 10 rounds through it just before I turned on the camera to get it zeroed. So we're warmed up and zeroed, shouldn't have any excuses here to start out with. Our first load, IMR 8208 XBR, it's 21.8 grains. So the velocity on our first shot was 27.14, and the piece of brass looks outstanding. No pressure signs or anything like that. So let's see if they'll group. That was a crazy shot. Okay, the average velocity ended up being 2689, but that 17.9 feet per second standard deviation is not good, and the group really wasn't good. So let's move on. 22.1 grains is next. All right, so this first shot going high deal is kind of weird. Take out that first shot, and the next four were a pretty good group. Brass looks fine, standard deviation tightened up. So next up, 22.4 grains. Everything was going good until that last shot. All right, so this is an extremely weird target so far. Very weird. Next up is 22.7 grains. Okay, last up with 8208 XBR is 23.0 grains. All right, we managed to hold it together for a decent group there. So we did hit 2,801 feet per second. That's pretty good. This last group of brass, I did see just the ever so slightest bit of an ejector mark on a couple pieces. Nothing to freak out about, but a little something there. So I'm gonna take a little break, let the gun cool down before we move on to Varget. Okay folks, break time is over. It's time to move on to Varget. First up, 23.8 grains. $24.1. Got my lucky butterfly on my scope. All right, are they all in there? Looks like it from here. That is awesome. All right, let's see if we can back that up with another good group. 24.4 is next. This whole target is just weird. Sometimes we're all over the place and sometimes it's acting like it wants to group. 24.7 grains of Varget is next. Okay, last up, 25.0 grains. Who knows how it's going to shoot? Looking at this target, it could be a 1/4 inch or 2 inches. All right, I'm kind of at a loss for words, man. A really weird target. Let's get back to the bench, see if we can make any sense of it. All right, let's start out with a quick look at the brass. This is going to be a pretty quick look because everything's fine, right? We kept pressures in check today for the most part. Our velocities were modest. This was our max charge of 8208 XBR. Primers are nice and rounded. No real problems to speak of. Out on the range, I thought I saw, like, is that a little ejector mark right there? Maybe a little guy right there. Maybe there. If so, just barely visible. And with this gun, that's usually our first indication, is we start getting some ejector smears as the loads get hot. But it doesn't look like we were anywhere near danger with Varget, or that was 8208 XBR. These are from Varget. Same sort of deal, maybe just some really light beginnings of some ejector marks, but primer's looking good. The rest of the case, other than being dirty, are looking good as well. So nothing interesting to see here with brass. All right, let's have another look at this target. I don't even know what to think here. So our worst group was the very first group at 1.698 inches. And our best group was clearly that second one with Varget. It was 0.356 inches. This is crazy. You just don't see this sort of spread normally on a target. You know, you see small improvements, incremental improvements. This was just massive differences. And it seemed like every group, from group to group, we had no idea how it was going to go. Those first three groups at the top with 8208 XBR, as we were shooting, I really thought it was trying to double group, right? Sometimes you'll see that where a gun it's like it wants to shoot two groups. We had a high point of impact right there at the bottom of the orange, and then a low point of impact about an inch below that. And a lot of times when you're seeing that, it'll eventually tighten up and start grouping, in one or the other spots. This one kind of met in the middle, like our fourth group, 22.7, is where it kind of stopped double grouping and kind of went in the middle, and then our best group with 8208 XBR at 23 grains was a little bit higher. So this, these shifts in point of impact are just weird, man. Now, Varget overall was a better shooter, right? Even our first group there, that's a 1.1 inch group. That's not terrible. And then we had that itty bitty group, and then all of a sudden, Varget decides to drop that one shot super low at 24.4 and screw everything up. So this is it's all just weird. And I don't really know what to think. I think in the next video with this bullet where we shoot through the other box, we'll test both of these good loads again. 23 grains of 8208 XBR, we'll load up some of those and do a verification of that. And then also, of course, 24.1 grains of Varget. So velocities were pretty low, right? We made it up to 2801 with 8208 XBR and 2837 with Varget. I think with the right powder choice, we should be able to flirt with 3,000 feet per second with this bullet out of my gun, my 18-inch barrel. So that's probably what we'll do in the next video. We'll load up the two good loads from today and verify those, and then we'll pick one more powder that I think can really get up there with velocity. Certainly 29 to 2950, and maybe even up to 3,000. And in that video, we'll also be loading up some to shoot into the ballistics gel that I mentioned earlier. I feel good about today's test though, because we didn't hit any unexpected high pressure. I was just a little bit weirded out by the whole thing, right? This steel type band being 2,000ths over our normal bullet diameter, and plus the bullet design, so close to the lands, or at least I think it was the lands. I guess maybe that seal tight band was hitting something else in the throat or whatever. I don't know, whatever, but we were only, 14 thousandths off what either the lands or something. We were only 14 thousandths from the bullet touching something in the chamber. So I just had a bad feeling we might run into some weird pressure problems like we have in the past. I wish these stupid things weren't so god dang expensive. I think there's clearly accuracy potential. Like, you don't shoot an itty bitty group like that with crappy bullets, right? It just doesn't happen, even by accident. So I think there's potential here. It's just, how many of them can you afford? I'd love to have a bag of 500 of them just to play around with stuff and maybe figure out what's going on, but it's just too expensive to do that crap. I do still have quite a few of the 62 grain Lehigh Defense copper bullets, and these are much cheaper. They're like 38 cents a piece. But the problem is I don't like the way these expand for deer hunting purposes. Great for varmints, I think, but they're cheap enough to where maybe we can learn on these and then take what we learn from these and bring them to the, more expensive bullets like the Cutting Edge and the Maker bullets. I've still got a bunch of the 62 grain Maker T-Rex. This is a tipped copper bullet from Maker. I feel like I've got a lot to learn about these sort of bullets and just no desire to pay $1 a shot to learn, if that makes sense. It's an annoying predicament. So I think that's where we'll leave it here, folks. If you've tried these out, have any powder recommendations, let me know. Or let me know, what sort of accuracy you saw with them. And thank you very much to the gentleman who bought these, or bought one of the boxes. He got in touch with me. He was interested in these bullets and donated the necessary money to pick up a box of them to try. So thank you very much to him. It's definitely an interesting design. No doubt about that. They've got my attention. So that's it, folks. I'll see you next time.